I'm Adrian from Redshift, showing you the Mighty Redshift Fog. But at first, the Redshift Fog, which is called the Redshift environment, might not look very interesting. And in order to get it, you need attenuation bigger than 0 and a different emission color than black. And you get your fog. And this is fine. And it's pretty much the standard for fog in computer graphics. It has nothing special about it. And if you need, for instance, a height fog instead of a depth fog, as we have here, you can turn on the height fog and then just have this, for instance, 3 meter high. But again, it's not very interesting. To make it more interesting, we have a predefined shader called the noise volume, which actually is just a noise shader connected to the volume output. And then we just throw this on the Redshift environment, and we need to actually disable the fog height and fog emission and just work with the fog coming from the lights. Well, in this case, our lights have no fog because the volume contribution scale is 0. So let's increase that. Without the shader, the scene looks like this. Well, that's fine, but it's too uniform. It kind of looks like just a regular fog. It doesn't give any interesting or any breaks in our fog. It's too uniform. That's why we have this, right? So this is the Redshift noise, but I can replace this, of course, with a maximum noise, which gives us way more noise patterns. In this case, well, the default noise might not be ideal. You might need to increase the scale, and you can see it working. But that's not enough. I just got some sort of noise on my fog. Well, this works up to a point, but I still want more control. And to get more control, we have to use a little nifty shader called state. The state shader outputs various data from the scene, but basically we're gonna need the ray position, because we're gonna try to extract two things. We're gonna try to extract the Y information to give the fog some height, and the depth information. And for these two, we're gonna use the world and the camera. The camera will give us the Z component as the depth information. And for this, let's extract the ray position Z coordinate from the state, change range so I can remap it, and then use this as a fog tint. Okay, so this apparently gives us nothing, and that's because, well, the old range and new range are the same. So let's try 0 to 10,000, and lo and behold, you see that we got some sort of depth fog. Well, I can use a ramp, and I can remap the result here. And because the ramp has controls, I can actually decide where this starts and where it ends. Let me just turn on progressive because it's faster. Check this out. So this actually controls where my fog starts and where it ends. And you know what? I can make it even crazier. It can be just at a certain distance and nothing more. Of course, in this case, I need to make the fog quite more intense to be visible, but it will be visible just in this small distance. The only drawback for this is that, well, we're remapping 0 to 10,000 into 0, 1, so just dragging the slider might give you meters probably. Okay, so you have to pretty much eyeball it. And if I go here and increase the scattering to something like 0.5, you see we have a kind of a wall of fog, right? And this, I can even come with this closer. Not so sure I'm gonna be able to compress this even more. Actually, I can. And this will give you just a kind of like a small bit of fog into the scene. So let's try to. There you go. Okay, and the fog starts here and ends somewhere there. Well, to be honest, I don't want quite this. I don't want to have just a slice of fog, so I'm gonna keep this to start somewhere and somewhere, and then I'm gonna just simply put this back to 0.1, which was great. And you have this tint, but when you have a shader that's assigned to the volume scattering, it's actually connected to the volume tint internally, and even if you make this red, for instance, it won't do anything because you have a shader that controls the color. Okay, so we've established that we can do depth fog ourselves, but we also can do noise. That means we can layer these. But how about a fog height? Well, remember, we can again extract some data from the scene using the redshift state, and in this case I'm gonna use the world space and extract the Y position and do exactly the same thing. And I want to, well, 0 to 1000, and in this case, because I'm using predefined ramp, I can actually get the fog to start from the ground. Let's make this white, and then using the slider, as you can see, I have full control over my fog height. And again, this is, we're going into crazy territory with having layers of fog. So I have some fog up here, some fog down here, and I can multiply this with different noises, and I can combine them, and it's totally flexible. So let's first, let's get something like probably so. Now I'm going to use a color layer to combine all these three. So we're going to start with the max on noise as base color. We're going to add the height fog as layer color 1 in multiply mode, and let's see what we get. So we get now this max on noise, this max on noise acting into this range. So we're combining them to get this. On top of that, we can add another layer, layer 2 color, enable this, which will localize the fog just in that area. And we're gonna put this into multiply mode as well. So basically, now I can set up my ramp and say, okay, my fog starts here. Y based fog, so height fog starts from here and ends up probably here. And on top of that, I have my max on noise, which gives us, it breaks the light, actually the fog intensity into the scene. And this makes the fog way more flexible. And of course, you don't have to use just one fog as I have here. You can use multiple noises. Okay, So this makes the whole thing extremely flexible. I hope you're enjoying this as I do making them. Happy redshifting. Cheers.